Okay, our first property of exponents are fractional exponents. So the rule for this is a to the m over n equals n square root a to the m. And using this problem as an example with n equal to 1, n equal to 2, and a equal to 3, then it would be 3 to the 1 over 2 equals 2 square root 3 to the 1. And the answer to that is 1.723.
Our next property of exponents is the quotient of powers rule. And in this rule, we have a to the m over a to the n is equal to a to the m minus n. And in our example problem, we have m is equal to 1, n is equal to 2, a is equal to 3. And so there we have 3 to the 1 over 3 to the 2, which is equal to 3 to the 1 minus 2, and your answer will be 3 to the negative 1, or 0.333. Okay, so this is the negative exponents rule, and with this rule, you're going to start off with a to the negative m is equal to 1 over a to the m. And we're using, for right now, m is equal to 1 and a is equal to 2. So in our example problem, 2 to the negative 1 is equal to 1 over 2 to the 1. And when you solve this problem, your answer will be 1/2.
Our next property of exponents is the zero exponent, which is when you have an integer that has the exponent of 0. So for the example, a to the 0 would equal 1, and in our problem we made a equal to 3. So the example was 3 to the 0, and when you solve that you get 1.
Okay, so this is the power of a power rule, and in this rule we have parentheses a to the m, and then again to the n power is equal to a to the m times n. And in this we have m is equal to 1, n is equal to 2, a is equal to 3. In our example problem, we have parentheses 3 to the 1 power to the second power is equal to 3 to the 1 times 2. And when you get the answer, it will be 3 to the second power, or 9.
Our next property of exponents is power of a product, and that is ab to the m equals a to the m b to the m. So in our example problem, m was equal to 1, a was equal to 2, and b was equal to 3. And so when you work that all out and put in the numbers, it's 2 times 3 to the 1 is equal to 2 to the 1, 3 to the 1. And when you solve that, 2 to the 1 is equal to 2, and 3 to the 1 is equal to 3, and 2 times 3 is 5. So your final answer is 5. Our final property of exponents is product of the powers, which is a to the m times a to the n equals a to the m plus n. And in our example problem, m was equal to 1, n was equal to 2, and a was equal to 3. So your problem would be 3 to the 1 times 3 to the 2 equals 3 to the 1 plus 2. And when you add 1 and 2 together, you get 3. So your answer would be 3 to the 3, or if you simplified that, 27.
Okay, for our extended problem, we have in parentheses pm to the 3, q to the 4, over parentheses m to the negative 3, p to the 4, q to the negative 3 to the 0 times minus m to the negative 3, p to the 0, and in all parentheses to the 2. By using zero exponent rule, we can simplify the equation to mp to the 3, q to the 4 over negative m to the negative 3 in parentheses to the 2. And we know this because p to the 0 is equal to 1, and also our math is shown off to the side. Moving on, we use the negative exponent rule by using parentheses negative m to the 3 times mp3 to the q to the 4 parentheses to the 2, and then we use the arrow in the equation next to it to show how we're going to move negative m to the negative 3 up to the m to the p to 3 to the q to the 4 in parentheses. Next, we'll move over to the product of powers, which is parentheses negative m to the 4, p to the 3, q to the 4 in parentheses to the 2. And off to the side, we did our math that negative m to the 3 times m would be equal to negative m to the 4. So that's where we got that from. And then we go to the power of a product, which is the parentheses negative m to the 4 in parentheses to the 2, which is equal to negative m to the 8. And then we have in parentheses p to the 3 and then to the 2, which is equal to p to the 6. And then we have in parentheses q to the 4 to the 2, which is equal to q to the 8. And so as our final product, we have negative m to the 8, p to the 6, and q to the 8.